the meeting. I was hoping that if anyone was coming in and is new, is coming in late, and joining us, please share what classes are you excited for next semester, and any of our officers or anyone can share their experiences, which would be fun because we all enrolled maybe, or if not, we can help you pick good classes or your schedule and everything. Awesome. With that being said, I'm gonna hand it to Soroush.
Alrighty, thank you for Jean. Thank you, Sean. Thank you, everybody. Good afternoon. Welcome to the second GBM. And as per the announcement, today we're going to talk about a fun little project we put together for this matter about game recommendation and how recommendation systems work in systems like Steam or Netflix, or well, Netflix is not really games, but well, it's pretty similar in the way they work. So um, let me share my screen first.
I think I just turned on screen share. Are you able to share it now?
I got it.
Okay,
Thank you.
cool.
Yes. Alrighty, can everybody see my screen? Fine. Yes, no,
Yeah.
yes.
Looks
Yes,
good,
yes.
looks
Yes,
good.
okay, awesome, awesome, awesome. All right, let me share the link to this notebook as well so you guys can also look over it, see if you follow through with the meeting. But without further ado, let's get started with this thing. All right. So, the goal is we want to understand the basic concept of recommendation systems and how they work generally. But more importantly, we're going to use machine learning, very simple algorithms of machine learning to um, uh, see how this can work in our favor. And for that matter, we're going to use a library in Python called a scikit-learn, which I don't know if anyone has heard about it. Has anyone known this beforehand?
I've heard about it.
Put okay, okay,
I've
Sean,
heard about it.
thank you. Anybody else?
Heard about it.
One's in the chat or something.
Me too.
Awesome, awesome. First time for Asaya. Okay. Clearance is 2. I've heard about it. Okay, so pretty much it gives us a lot of functionality in different aspects. For example, today we're going to go over support vector machine, or SVM, which we'll get to in a second. But there are a lot of different types of supervised machine learning that you can do with this tiny little powerful library. Um, let's see. Any questions so far about scikit-learn? Okay, let's continue then. What is SVM? I've said it like 10 times now. What are you talking about, Soroush? So SVM is pretty much a machine learning algorithm used for classification in regression tasks. It works by finding the optimal hyperplane that separates data points from different classes in ways to maximize margin between them. I put on a chart over here to demonstrate it. Let me see. Okay, so we have a dotted line in the very middle, which is our decision boundary saying, oh, something is either, let's say, let's just go with the colors. Let's say it's red or it's blue, right? When you use support vector machine, you are drawing a pretty simple line to have a detection or a hyperplane between each of those classes, separating the possibility of each class and making it more accurate in the sense that, oh, they're not going to go over the let's say the decision boundary that we defined in the very beginning. So you will see how this works when we give it some more data, when we give it any data. But just for the sake of demonstration, let me see if I can draw some little things on here. Okay, I'm gonna pause the screen share for a quick little moment.
And I think this is a good time to say that anybody has any questions, feel free to put them in the chat, and Soroush will happily answer them for you. Since I know there's a lot of people here, first time they've even heard about, you know, like SVMs or just like even machine learning in general. If you have any questions about anything, Soroush will be happy to explain.
Absolutely. Um, let's see this. Okay. All right. Assuming everybody can see the smiley face I drew on the page. Yes, no. Okay. Just stop the share, reshare. Maybe this helps. There we go. Okay, awesome. Sorry about the technical difficulty there. Okay. So I'm gonna annotate over here. All right. So if we assume that you have different types of data, let's say we go with the shapes that we have over here. And we have different shapes, maybe like squares, triangles, circles, and different colors. Let's say we have green, blue, and red. On a regular basis, when we want to change this data to be, let's see, we want to make sure this data is classified in a way that we can actually use them. We separate them. What does that mean? Let's say if I have these red little circles over here, these are, let's give them a name. Let's give them a name. Let's give each of them a name. Let's call these QB. Let's call these apples. Right. Each of these things are going to have different attributes to them. For example, an apple might be 20 centimeters in diameter, in size. Getting involved in student publications, media is like. Did anybody have a question? I heard something. Okay. So let's say we have a 20 centimeter in size for the apples, and we have the same size attribute for the cubes being, for example, 30 centimeters. This one would be maybe 35. This one would be 21. This one would be, let's say, 18. This one would be 23, for example. Now, if we go down here and then say this one's 20 centimeters, this one is 17, this one is 18, and this one is 22, right? With that one attribute, we really cannot say, oh, this is a red apple, or this is a QB, a colorful QB, for example. We will need more attributes than that. So, assuming that we already gave these things to our computer for machine learning, what we will need to do later is to have a more accurate model. We have to give it more attributes. For example, these are red. All of them are red. Red. This one is red. Red and red, and this is C, 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 C for colorful. Everything clear so far? Okay, awesome, awesome, awesome. Now, let's see. Okay, as we give it more attributes, these will get more and more manageable in the sense of data structuring the data. But one thing is still missing. Even though we will have some things that have different sizes, different colors, we don't know what they are, or the computer does not know what they are. Here's where our SVM model comes in, or scikit in general comes in. We will use something called supervised machine learning, which will allow us to pretty much give the input to the computer. And also the output to the computer. Now, can anybody tell me what is the difference between supervised machine learning and unsupervised machine learning? Sean, go ahead. I see a raised hand.
Thank you, Soroush. So if I'm not mistaken, for unsupervised machine learning, they're only given the input, but they're not given the output because there's no direct correlation, at least when they're giving it to them.
Correct. Exactly. Spot on. So the difference between supervised and unsupervised machine learning is that unsupervised, we give our model both input and output. But on unsupervised, we only give them input because there are no particular way that we can just say, oh, this is the output for all of them. It's a little mix and match, but hopefully in later GBMs, we can get to those as well. But getting back to this, let's see. After we put in our data and give it all of the attributes that we have also told our model that, oh, by the way, these things that you plotted points for, these are blue squares, and these are red circles. So any prediction that it's going to make is going to be between this margin mostly. It's going to be between this margin. Excuse my amazing drawing skills, by the way. I forgot to say that earlier, but anyways, any questions so far? SVM is clear for you?
I have a question.
Go ahead. Go ahead.
So does this mean SVM would be a supervised machine learning model or unsupervised?
Ah, okay. Let's ask the chat. 1 for supervised, 2 for unsupervised. Hit me. Okay. We have 2, 1, 1, 1, and I don't know, and 1. Majority is saying 1, and 1 is correct. The reason for that is we are dividing these two sections by telling them, oh, these have all these attributes. By the way, they are squares, or by the way, they are circles. So on SVM, on support vector machines, we will have to give both the input and the output. So going over the chat, I see a couple of questions. The computer give the output. I think that comes a little after what you're asking, comes a little after. So the prediction for the output is something that we'll talk about, which will be the output of computer based on a test data or a let's say something that's outside of the data set that you give it for training to it to evaluate. For example, let's say you've talked about Overwatch, Fortnite, and Rust. Those 3 games. You've talked about those 3 games, right? The 4th game that you're going to give it is, let's say, the game you're going to ask about it is going to be, did I say Call of Duty? No? Okay, then let's say it's Call of Duty. If it is Call of Duty, then it will say, oh, the stats of this, the genre, the pricing, the overall feel of the game is a little similar to, for example, Overwatch. Not pricing. Activision's a little greedy nowadays, but we don't talk about that. So it will recommend, for example, oh, since you're talking about Call of Duty, let me recommend you Overwatch, for example, or Fortnite, since they are both shooter games. I hope that answers your question. I'll guess that Joshua asks, I'll guess that would involve how they're instructed, since unsupervised has no way to check the output. Correct. So when you talk about unsupervised, it's like giving the computer instructions for something that it doesn't know how to do. For example, let's say walking. You make a tiny little robot and just tell it to walk. It doesn't know how to do it. It just, how do you say you need to walk? You say go from point A to point B, use your, for example, arms and legs to move to that place. It will try and try and try and try till it gets to a optimal solution in its own head. It might not even be walking. It might roll over itself. It might jump. It doesn't really have a particular structure if you don't define the attributes quite accurately. Does Steam, Clarence asks, does Steam have its recommendation using supervised or unsupervised ML? So Steam itself has it over supervised because if you think about it, Steam is has one of the biggest collections of any game library that exists. They have a lot of games. All of those games have a lot of data, a lot of feedback from users, a lot of information about what is the genre, how long does it take to complete the game, is it multiplayer, is it not multiplayer, How's the graphics? Is it 2D? Is it 3D? Does it support ray tracing? Does it not? All of those factors will, excuse me, all those factors will allow for something that makes it easier for them to do supervised machine learning for recommending games. Hope that answers the question. Keith is asking, so unsupervised ML is essentially the machine brute forcing result. Not necessarily, but in most cases, in most simple cases, yes. Okay, let's continue.
And to
And
try
I'll answer
to,
to,
I was gonna add on to
go
your
ahead.
last response to Keith. From my knowledge too, unsupervised machine learning, you're given a lot of data, again, that's not really labeled. You're just given a lot of these like attributes, but there's no like directly correlated output with them. And the way that they use it usually is to try to find relationships between parts of data. But that doesn't exactly mean that there's always going to be like a correct output at the end of the day. Maybe these relations will like give you something else that you might be looking for or that might be useful, but it's not always just gonna have like a result at the end of the day.
I appreciate that, Sean. I could not have said it that well. Appreciate you. Um, let's see. Samuel in the chat says, I know nothing about AI. Feel free to reach out to me on Discord. I will let you know if you need any help with starting from anywhere. I'll give you some sources and everything that you will need. Alrighty. Let's continue, shall we? All right, so to the code that we want to go over. For recommending system, there are not a lot of things, not a lot of libraries that we're going to use. It's going to be pandas, NumPy, and scikit-learn, which is sklearn here. Matplotlib, which is a library for drawing graphs, is optional, not required for this one. But it is optional if you want to draw out a figure or a graph at the end of it to show what the output would be. Pandas and NumPy, I'll explain as we go. As we get to the code, I'll explain what each of them are doing. So going to the next portion is our data. So I put in some test data with some games, just to go over. It's not that these are my favorite games, absolutely not. Don't think that way. I try to be very unbiased putting these games. Call of Duty, of course, is, but Call of Duty, Minecraft, Sims, Mario Kart, Cyberpunk, Overwatch, and Stardew Valley. Now, as you can see here, I have all of the data inside of a dictionary. You may be asking, Soroush, why is that? Well, in answer to that, I'll tell you, my dear, be patient. We'll get to that. So I'm kidding. I'm kidding. So let's see. Graphics. Inside of this dictionary, we have a bunch of different, let's see, a bunch of different attributes. For example, we have graphics, we have multiplayer, we have age, difficulty, genre, price, and then favorite, which is the list of games itself, right? Now, to explain what is going on over here, you can see each of these keys is bounded to a list. These lists are indexed, for example, with Call of Duty being index 0.
Good to see you. Good to see you too. Even pretty hectic. We have
Minecraft being index 1, Sims being index 2, Mario Kart 3, Cyberpunk 4, 5, and then 6 were Stardew Valley. Now, everything inside of these lists correlate to those ones. For example, graphics of Call of Duty, I'm saying it's 9 out of 10. For Minecraft, we're saying 7 out of 10. 8 out of 10 for Sims. Mario Kart is 6, and then 10 is for Cyberpunk, 7 is for Overwatch, Stardew Valley 8. Each of these get linked to each other using just simple indexing inside the lists of this data dictionary that I created. I hope everything is clear over here. Let's see.
I think
All
Alan might
right,
have a
now.
question in the chat.
Oh, let me see. Key value pairs grant a unique key for accessing. Key value pairs grant a unique key for accessing. Well, oh, we have a follow-up with that. Wait, so like the keys are the titles and each value is paired with the value in the same indexes in other keys. So yes, technically yes. So if I were about to show you how this will look, put it in a, if we put it in, for example, something similar to a Excel sheet, we have how many of these? We have 1, 2, 3, 4, 5, 6, 7, right? 7 rows. I don't know how many is that. And then each of these is going to be the attributes that we're looking for. So for example, graphics, it's not drawing, multiplayer, age, difficulty, genre, and price, and so on and so forth. These get all bounded to each other using the index of their list inside of this dictionary. Pretty much when we use pandas to put it in a data frame, this is exactly what we're doing, right? So the way this works is as we put them inside of the data frame, later on you will see that we bound them as, who asked the question? As Alan said, yes, as Alan said, these are going to be bounded to each of the attributes inside of the dictionary. For example, when you say DF, which is the data frame, graphics, you're looking for the graphics, it will show all of the graphics over here, which is going to be a whole column inside of here, right? When you say multiplayer, it's going to be column number 1. It's going to be, when you say age, it's going to be column number 2, and then 3, 4, 5. And then favorite, it's not going to quite be there. This is going to be our output. Inside of the data frame, it is going to be there, right? But for, it's going to be for a X and, let's see. For the inputs, we're not going to put in the favorites inside of. So it works like a named tuple. Sort of. Yes. You can say so. Yes. Yes. You can say so. Thank you guys for being active in the chat. I really appreciate that. Let's see. Okay. For testing purposes, after I gave the data to the data frame using, after I converted the data into a data frame using pandas, I want to select some of the features and train a model from it. How do I do that? So we pick, for example, let's say graphics and graphics and difficulty for visualization and create binary labels to group games into two classes, low graphic and high graphics. You can, the reason I put so many of these is because I want you guys to experiment, run it by different things and see how, what results you guys get. I chose for this demonstration graphics and difficulty. And then on Y, go ahead.
Oh, sorry, Soroush. For the actually kind of the questions based around how the data frame worked and how the data was all related to each other. In that last box you have there, if you just do the print df.head, Pandas has a really good visualization tool and really like it made basically the same thing that you were trying to make on the table. And do I think parentheses right next to head because it's a function technically.
There we go.
And then try printing
Is that
that
it?
out. Yeah.
Okay. Let me
Oh, you're gonna
run
have
it.
to run all from the start, maybe.
It's fine. Here we go.
Yeah.
Bingo. We have indexes on the far left, graphics, multiplayer, age, difficulty, genre, price, and then fave, which is the output. Thank you, Sean. Appreciate you guys. All right. So, is head a built-in function? Yes, it is a built-in function. You can give it a number and data set is too big. Correct. Also, for Jean, thank you. Yes, you can give it a number if your data set is too large. To limit what it's showing. Let's see. All right, back to this. So you can pick a range. Yes, you can pick a range. What do you mean by rating, Keith? Looking at this set, what are the attributes you could help improve recommendations? Rating would be a good one, actually. Yes. Agree. All right. Continuing with this, let's see. So now we're going to fit in our graphics and difficulty values inside of our X. Just like the way a graph works into axes. So these are going to be for the X axis, and then for the Y axis, we're going to go graphics that are higher than 8.5 as a type integer inside of values. So why are we using binary classes over here is because SVM is usually better when you separate two classes. It is very limited in that sense, but it gives us a good intro and understanding of what is possible. You can try it with more attributes if you would like, but I'll leave that up to you guys to see how it will work out at the end. Afterwards, let's see, we scale them into, we use standard scalar to make them into scalar format in order for us to be able to use them properly and then graph them in a sense. Very simple. We just initialize a standard scalar and then we fit our data set, our input, the data input inside of our scalar, which will give us a scalar version of the X. Now, it is time for us to train our support vector machine classifier. Excuse me. Okay, so continuing with this, we are going to train a linear SVM model to find the optimal decision boundary separating our two classes, which are, what were the two classes? Does anyone remember?
Apples and QBs. Yes. 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 Yes.
Yes. in this data set, though. In this graphics and difficulty, X and Y. Graphics and difficulties. Okay. Okay. Not bad, not bad. Okay. Correct. So we are going by graphics and difficulty for the classes. However, we are rating them based on graphics that are higher than 8.5 and lower than 8.5. So difficulty is a class that will help you separate your apples if they have. It's like the tiny little dots and like holes that you see on apples that separates them, differentiates them. But what we are classifying is based on high graphics and lower graphics. So X and Y is by clearance is correct. Joshua, you're also correct. Keith, you are also correct. Thank you, guys. Going down, let's see. We mentioned that we're training it based on we're training it on a linear kernel. And the reason for that is on the demonstration that we had up here, we went over a linear boundary for this. It is possible if you want to do, for example, nonlinear ones, cosine, sine, all of those are possible if you want to have your boundary to be set in that terms. It is also possible. However, to make it easier, and since we have a very small data set, I think linear works just fine with this. So we'll just continue with that. And we also have another, let's see, we have another attribute here, parameter here inside of our SVC, which is C equals 1. C is the margin size. So if we go back to here, margin size is the distance between hyperplanes and our decision boundary. So if we are able to, for example, we can play with this number, make it bigger to make a bigger boundary, or make it smaller to make a tighter, more accurate representation, or accurate closer to the boundary, pretty much, decision boundary that we have. Any questions so far?
I have a question. Might be a little bit of a hard question.
Go ahead.
Um,
Go ahead. Hit me.
so, if say you make the decision boundary, or not the decision boundary, but let the margin between the decision boundary large, and if you scroll up to that example you had up there, what if you make it large enough to where there's like some data points on the inside of between the margin and the decision boundary? What happens to those? Are those able to be classified correctly?
I did not catch the last part of your question. If you can repeat that.
So, like, if you create the margin and decision boundary, that space to be big, and say in this exact picture, if you made it a little bit bigger, you see how the two cubes would be on the that kind of like between the decision boundary and that margin line.
Right.
Does that mean that data just isn't considered, or what does that mean?
No, it means so they are still classified because our boundary stops over here. It's on the dotted line. Wait, not drawing again. Hello. Pen is not working. Sweet. Okay. Oh, Jesus. All right.
I think Fojan got it for you.
Appreciate that. Thank you, Fojan. Thank you. Okay. Thank you for the save. Okay, so internet is not good here, so let's see. So yes, the decision boundary is what separates the classes. the hyperplane lines that you see are pretty much just separating the distances between the classes. So what I'm trying to say is you still have a classified, two classified objects or classified classes, let's say. You have classified your data into what you need, but the margin for the prediction is going to be larger.
Sounds good.
Does that make
Sounds good.
sense?
It does make sense. Thank you for the clarification.
Yes? Okay, no problem. Thank you for asking questions.
I think you have one more question in the chat, by the way.
No, wait, let me see. Is it like using linear correlation? Coefficient test. Can we say that? Can we say that? You can say that, I think. I think yes, you can put it in that terms as well. Is there a separate degree for AI at CSULB? That is out of my expertise, unfortunately.
No, there is not, sadly.
Just electives? Okay. All right, moving on. Since we're getting close.
Yeah, sorry
Go
to cut
ahead.
you off again. For Clarence's question, I'm not too sure off the top of my head, even though that's a good observation, especially in our specific example with just having it be a linear model. But all of the documentation for like the standard scalar and stuff is online, so I'm pretty sure if you just look up the documentation, it should probably say exactly what it's like. But yeah. Okay, go ahead.
Thank you for the clarification. Okay. Lastly, after we're done training our model, how? We created a object or a model pretty much with SVC. Then we fit our input and output into it. This is going to create us a model, a SVM model with the data that we implement into it. Now we are able to start predicting. Now, how does prediction work? We first would have to extract features of our target game. So assuming that, let's say, can someone give me a game that we had over here as a target? First one who puts one thing, it wins. First person. Sims wins. Okay. Sorry, Pujan. Sorry, Sean. Sims wins. Sorry, Joshua. Guys, listen, COD is my favorite too, but I made the rules, but anyways, so in the function over here, we have a game index and a top end. We'll get to top end, but the game index is pretty much the index of the game inside of the data dictionary that we created earlier, the list of fave. So if you guys remember, in fave, we had a list in front of this guy. As we know, lists are indexed, so each of these games will have an index. Assuming we're going with Sims, Sims is index number 2. So here we're saying the game features is X scaled on index 2 dot reshape to 1 and -1. Well, let's see. And then we compute the distances between our decision boundaries. We fit in the X scaled into the SVM model. after that, we sort all of the similar games that it will give us back based on the index that we initially got started with. When we are done with that, we exclude the target game itself because it is going to be its own recommendation, obviously, and we return the list of recommendations. Now, we had one parameter here called top n that we used over here, and that is because over here our function will return a few of these. It will give us a list of games that are similar to, for example, Sims. So let's see. If I put in, let's say, it will give out something. I'll print it for you guys to see as well, but let's say COD and then similarity like 0.7, for example. And then we'll have Minecraft similarity 0.5, and then so on and so forth. So as many top ends as you have over here, if you have 2, it will show the top 2. If you have 3, it will show the top 3, 5, and then more and more comes. So let's see. After we're done with that, we just give it the game index that we're trying to do a recommendation based on, and I set a default to Overwatch over here, and we will run our that's a very, very horrible line. There we go. Now we have our, we call the method and save the results in there, and at the very end of it we print the results. As you can see, we have a list of recommendations for Overwatch printed over here. Now, what game did we ask? We asked for Sims. What was index of Sims? 2. Let's try to see what Sims will give us in similarity and if it does make sense. It gave us, whoa, Cyberpunk and Call of Duty. Now, in my defense, we did it based on graphics and difficulty. So in those 2 things, it will make sense. Now, experiment with different attributes that we have over here and see what fits better for you guys. What will give you the most optimal results based on what you like or what you put in here, if that makes sense. So that would be all for the project for this GBM. I am free to answer any questions for you guys over here. Shoot me. Sims is pretty hard. I agree. Yeah, it is pretty similar. Listen, guys, come on. It's in difficulty, and what was the other one? I forgot. Graphics. Graphics of Sims is pretty good, considering. Well, let's try something else. Let's try Cyberpunk. What is Cyberpunk? 234. What's your bets on? What are the 2? What are the 2 games that it's gonna tell us, recommend us? COD and Sims. Okay. Let's see. Run all Mario Kart and Overwatch. It changed a little. I'll explain why this changed, but let me answer Clarence's question first. Okay, so let's see. To learn all these functions and syntax, do you just read up on manuals for all the libraries? How do you know what libraries you need to use and stuff? Okay, so that is a great question. It depends on what you are doing. Starting, it is better to, how do I put this? it is good to start with a source that you just have a project to go with. Then you will understand the use of each library. For example, what scikit-learn does, what pandas do, what NumPy might do, and each of those will give you each of the projects that you do will give you another perspective or open up a new dimension of the features that a library might have. Again, scikit-learn, we just talked about what? We just talked about support vector machine. There is a lot more that you can explore with this thing. K-means, there are a few unsupervised things that you can try with it. But processing data, those types of stuff, you usually use NumPy. How do you know this? Is just by trying with different projects. You just go, oh, you try to fit in something and it doesn't work. It's like, oh, this data type does not really correlate with this thing. And then you search it up, you look in the documents and it says, oh, you got to use NumPy to, for example, make your data into what you need and then use it inside, for example, a support vector machine. They have a lot of they get a lot of cross references between the documentations just to show what is needed for each of them. So you can use those as reference as well. I hope that answers the question. Just look at the documentation. Yes, thank you, Keith. I appreciate that. So learn through projects we want to experiment with. That's my way. That's what I like to do, honestly. Because learning, you can just sit there and watch like 2 hours of Bootstrap on YouTube. I'm not saying it's not useful, but if you don't do a project with it, you're going to forget it like in 10 minutes after the video. And I think we have done something similar. All of us have done something similar to that. So I've heard about weight and bias of to generate an output where the weight is multiplied by input and bias is added in a function that takes input X and generate output Y.
I could kind of help with this one.
Go ahead, yes.
For that question, Alan, so the way that scikit does it is it's really simplified. If you go up to, I think, the fifth cell number 5, it's literally just one line where we initialize the model and then we fit it with the data. So there's also a lot of other optional parameters, and this is where the weights and biases could come into play. And I'm sure there's options out there on scikit. I couldn't tell you off the top of my head for SVM specifically. But on the back end, SVM is all created with like NumPy. And if you really wanted to learn more about how the model works in general, there's a lot of tutorials out there on YouTube where they just create the model from scratch using NumPy. And that's where you're really going to learn how all the weights and biases, come into effect. That being said, scikit is the best tool to use if you just want to create the model to do what you're trying to see and start playing around with data and start, making data-driven projects. But if you are more interested on like the numbers side, you could always do that. No problem. I think Keith also put a great answer there in the chat. But yeah,
Yes,
go ahead, Soroush.
I was about to say Keith answer is also really good. Thank you, Sean.
Problem. I see we're kind of running towards the end of the meeting here, Soroush. Should you want to say any final statements?
Final statements. Just work with the Google Colab a little bit if you guys would like to, and hit me up on Discord if you have any questions. If there were any things that were not clear, just hit me up, let me know, and I'll be more than happy to walk over. I will put my Discord in the chat as well.
Right. Thank you so much, Soroush. Really
Of course,
appreciate
of
it. Great
course.
job today. Can I get some claps and thank yous in the chat for Soroush? He did an amazing job
Appreciate you
leading you
guys.
guys through this short time frame, a lot of new information. And of course, like he said, he's putting his Discord in the chat, so please reach out to him or even in the questions channel in the Discord if you guys have any more questions about this. This recording will also be uploaded. I'm gonna get GBM1 and GBM2 uploaded to our YouTube today, and I'll put a little announcement out later when they are if you guys want to go back and watch everything. Um, but yeah, I hope you guys enjoyed today's GBM. I know we went a little bit over schedule, but thank you guys so much for everybody that showed up to our second GBM. Unfortunately, it is still online, but I love the turnout and how many people came and decided to spend their time with us during, this busy midterm season before break, turning in projects and whatnot. So I appreciate you guys. If you guys have any other questions, we'll probably stick around for a couple more minutes. But if you have to go, feel free to leave questions in the questions channel in our Discord. But yeah, thank you everybody.